Hi guys, welcome back to the shop and hello to any new viewers. Now in the last video we looked at batteries, covering the types of batteries there were, the capacities and voltages, testing a battery, and then a sort of an introduction to charging as well. Now in that video we used the vehicle itself, which is a 3-litre diesel Jeep, to test the capacity of the battery and see what the voltage drop was whilst we were cranking or turning over the starter motor. That's a fine way of doing it and it works well. But since then, given the fact that we have a number of vehicles around, including ride-on lawnmowers, tractor, a number of cars, etc., I thought it might be time to upgrade my battery testing capabilities. And what I did was I went out and I bought an electronic battery tester. Now this one is, I'll hold it up there. It's a Draper 81164 battery diagnostic tool. I didn't set out to buy this one specifically. On the third motor shop that I tried, they had one, so that sort of simplified the purchasing decision, and it was a sort of a take it or leave it type of gig. So anyway, bought this, €90 it cost me. This video isn't sponsored or anything like that, to my own money. And what we'll do now is we'll have a look at the various tests available on this. Even though different battery diagnostic tools will have different features and so on and so forth, there should be a commonality between different types of batteries it tests and the different tests that it runs on those batteries. So as an introduction, this one is a 12-volt tester. It covers lead acid, AGM flat plate, AGM spiral, gel batteries and EFB. And we covered 4 of those in the previous video, and the only one we didn't was what's called an EFB, which is an enhanced flooded battery. Now effectively where you'll find these EFB, gel and AGM batteries is in a lot of vehicles that do a sort of an automatic stop-start at traffic lights to reduce idling time and increase fuel efficiency. And what they're designed to do is perform a much better deep cycling, whereby you can start the vehicle quite a number of times out of the battery. The battery can run down quite low without doing it any permanent damage, or sort of less damage than a normal flooded lead acid battery. Just to run through our battery types again, the oldest type we have would be a flooded lead acid battery with little caps on top of it that you can open, and you can recharge the fluid inside with purified water. The fluid inside them is generally a mixture of sulfuric acid and pure water, 65-35%. The next stage beyond the old style flooded lead acid battery is a sealed lead acid battery, and we'll say, I'm not too sure whether you can hear it, but this is a sealed battery. It's sort of maintenance free, but if you slosh it, you can still hear the liquid inside in it. So that's a sealed flooded lead acid battery, and most of those will have a vent on them. The vent is designed that if the pressure becomes too high in the battery through overheating or too much gassing, that it'll let off that gas, which is fine, but that it shouldn't do that too often, and it should maintain the gases within the battery and maintain the liquid. The next step up from that then is a gel battery, and the gel replaces the liquid in the battery chambers, and it's effectively maintenance free. There's not much you can do with it. It's sort of leak free as well. Okay, generally more expensive though. Then going on to the sort of the top level batteries, which would be EFB, enhanced flooded battery, and AGM, either flat plate or spiral. And the EFB ones still have a liquid in them, but they have a design inside the battery, I think, that recycles or sort of recirculates the liquid in the battery to keep it mixed up and to stop what's called acid stratification, whereby the acid separates down the bottom of the battery and it deteriorates all the bottom of the plates of the battery and reduces your battery capacity quite quickly. So we say it uses the vehicle vibration, and it effectively sort of pumps around the liquid and sort of keeps it mixed and in good order. That's the EFB ones. And then on to the top level then, which would be AGM, either flat plate or spiral, and all that is a construction difference, whereby the electrolyte is actually absorbed into a glass matting. It's in a non-liquid form, and that can be wrapped very, very tight, so you end up with quite small batteries, and you can end up with quite high energy density batteries as well, but obviously then they're more expensive. So what we'll do is we'll take this out, we'll run through a few battery tests and see how it goes for us. Now, opening up our box, which I did already, and then I repackaged it for good content purposes. What we have here is, we'll get rid of the packaging. We have our small screen with buttons, and then we have two very short cables with a red and a black crocodile clip, obviously for connecting onto the battery. The red one onto the positive terminal and the black one onto the negative terminal. So we have a little book as well that comes with it, which covers off safety information, some specification, and then it gives us sort of poor enough instructions then after that. I've noticed a few typos in it. In the cranking test section, one of the boxes is labeled as charging test, which is wrong. And then in the box below it, during a cranking test, we have a 19.12 volt reading from that. So that's obviously a mistake. It should be probably 9.12 volts, which is sort of where you'd expect it to be. So we'll take the instructions with a pinch of salt, and what we'll do is we'll connect onto our known good battery. Okay, so now in the instructions, it indicates that anything less than 7 volts and the machine won't work. So what we're looking at there now is, it tells us the version, which is 806, and then it gives us a voltage reading of 12.63 volts. So this battery is a known good battery, and what we'll do now is we'll sort of try and test that and see what it comes to. So going into our machine anyway, if we press the menu button, it brings up a pile of languages, English, French, German, Spanish, Italian, Polish. We'll pick English, so that's fine, and that gives us OK. So if we press the OK button, then what it'll do is it'll give us our range of tests. And what we can see here is we have a battery test, a cranking test, charging test, and then review data. So it obviously retains the information on the screen whilst we're having a look at it. So we'll go into our battery test first anyway. Click OK. It'll give us a range of different battery types, they being regular flooded, AGM flat plate, AGM spiral, gel and EFB, which we've covered already. This battery is a regular flooded, so we press OK. And then what it'll do, down in the bottom right hand corner there, you can see that it's 1 of 10. There's 10 different testing standards that we can test to. And the difference between those standards is different temperatures, different loads that the battery will be put under, and different durations as well. On top of the battery, and what we'll try and do now is have a look at the top of the battery. Right, on our battery sticker here, it says that the model number of the battery is a 663, 750 cold crank amps, and it says SAE after that. So that indicates then that this was tested to a Society of Automotive Engineering standards. And then the capacity of the battery is 105 amp hour, and that's measured over a 20-hour discharge cycle. So that gels with, no pun intended, the SAE, or sort of American classification for testing. So what we can do then is we can take our tester, try and get it visible again, and we'll go down to SAE. Okay, and then we'll press OK. Right. The next screen that comes up then will be that you input the cold cranking amps of the battery, and in this case it's 750, so that's up on screen already. If you want to change that, you press the up arrows or the down arrows to achieve your 750 cold cranking amps on that. When you've that done, you press OK, and it'll go through a testing procedure. Okay, and what we're getting there now is our testing report, which is healthy. We have a green light on top, which tells us that the battery is sort of generally good. 85% of our cold cranking amp capability at 695. Charged is 98% at 12.6 volts. And what I'll do is I'll stick up a chart on screen there which tells you what state of charge is according to the voltage of the battery. Internal resistance is 4.28 milliohms, and then rated 750 amp, and this is a good battery. Okay, so what we'll do now is we'll take this off this one, stick that aside. We'll have a look at this battery now. This is a Varta battery. H14 is the model number. I will try and turn this. So we'll turn this way now. And down the bottom here, it says 12 volts, 102 amp hour, 680 amp, and then it says EN after it. So what we'll do with this battery is we'll use the EN testing standard. Okay, and what we're getting there now is 12.14 volts. According to the chart that we've laid out there, that sort of indicates somewhere between 25 and 50% charged. So you'd say to yourself that here, this battery, all it needs is a good charge. But when we go into the testing parameters then, if we click OK, this is, battery test, yes. Okay, we go into regular flooded, and this is a regular flooded, albeit that it doesn't have caps on top of it. So we press OK. And what we'll do now is we'll go down and we'll find the EN testing procedure. So that's it there, and we press OK. And our cold cranking amps for this battery is 680. So we'll get that there. We'll press OK. So it's testing. Okay, and what we have is a bad battery there. So the battery is only 2% healthy at 105 cold cranking amps. It's charged to 23% at 12.14 volts, and the internal resistance then is 25.25 milliohms. So the recommendation on this battery is replace. This would make sense. I've tried to charge this battery before, and it has come up to a decent level of charge. But what's after happening in that battery now is that the plates are corroded or sulfated, and there's very little of those plates left to hold the charge. So what you can do is there, you can get 12.25 or 12.4 volts, no problem, but it only lasts like a few seconds when you turn a starter or put a load on the battery. So that indicates to you as well that testing the voltage of a battery is not a definitive test by any means. It'll tell you the state of charge, but it doesn't tell you how much of the battery is good. Now those plates, they do go over time. It's sort of a service deterioration is called, and the way that happens is through charging cycles, heat, vibration, cold as well, contraction and expansion of the plates themselves. And then the lead plates break down over time in response to it being covered with the sulfuric acid. So that just gives us a general view of the health status of the battery. I found it to be pretty good, and it's matching up with my expectations of the batteries, some of them which I know are good and some of them I know which are bad. Okay, right, on we go. Now we're back at the Jeep that we tested the last date. That was about 10 days ago. So I'll be expecting the battery to replicate the same test results, even with the different style of battery tester. Now what I did was I took off the tie down strap, this fella here, because the specifications of the battery were right underneath that. So what I have here is a Monbat. I think they're an Irish company called Monaghan Battery, and kudos to them for having information up on their website as regards their battery ranges, the specifications of the battery and other important data. Having access to that information is very valuable to us. Now what I did notice, this is a dynamic series battery from Monbat, and it's not recommended for vehicle start-stop technology. This is a start-stop vehicle, although it's not used that often because all my journeys are long journeys as opposed to in the middle of a city. I live in the countryside. But one point to watch out for is whenever you have a sensor like that with small cabling going onto the battery, that would be a battery indicator or a battery sensor, and that will indicate to you, generally speaking, that you should be looking at an EFB battery, a strong gel battery, or possibly even an AGM battery, because that will generally indicate a start-stop requirement for the battery, which is a heavier duty load on it. Okay, here we are. I'm connected up to the battery. This is just a normal sealed flooded lead acid battery, so that's the options we'll be taking. This is giving us a reading of 12.72 volts. I'll look up the tests we did the last day with just the multimeter and see how they tally with the tests off the diagnostic kit here. Right, away we go. Battery test, yes, flooded lead acid battery, that's good. On this battery now, it doesn't tell me what the 850 cold crank amps is tested to, so there is an option on this for just straight cold crank amps. I think that generally marries up well with the SAE and the EN tests, so we'll pick OK there. We need to up this now to 850. Okay, 850 cold crank amps, and then we'll press OK. That'll test for us. Now what we have here is healthy battery 84%, it's giving us 790 cold crank amps. The charge is 96% at 12.69 volts, and the internal resistance of the battery is 3.83 milliohms. So that's telling it's a good battery. So what we'll do now is, while we're here, we'll move on to both the cranking test and a charging test and see what they do for us. Okay, to run onto our cranking test then is we go into our menu, second one down, cranking test, click OK. It tells us to start the engine, which we'll do. Now, what our diagnostic tool is telling us is our time that it took to crank was 9,000 milliseconds. The cranking was low, and we're dropping our voltage to 9.38 volts. So that does seem low, so I would be expecting that this battery is only so-so as regards cranking capabilities, and that possibly during the winter then that I might have issues with this battery. Okay, so that's our cranking. Right, and what we'll do now is we'll investigate the charging test. To do this now, I'm going to need extension or jump leads to be able to get this into the cabin so I can follow the instructions on it. Now what I've done is I've run extension cables through to the cabin of the Jeep. I have then clipped onto the door so that there's no chance that they can touch off each other. If you dead short a battery like this, there's nearly a guarantee that you're just going to cause a fire and melt cables. So that's obviously a no-no. Now what we have here is we have the engine started, and we're just about to go into our test meter now. So as you can see there, that the voltage on the screen is 14.7 or 8 volts, which would be normal for an alternator. We'll go down to our charging test. Okay, ripple test. Try and get that as big as I can for you. Right, decrease RPM to 2,500. Okay, and the results of our test are loaded with 14.54 volts, unloaded 14.63, and then ripple test looks like 14 millivolts. So our charging is normal, so that indicates that our alternator is fairly healthy. Right, now that we've done our testing with our new tool, this is just to sum up or close up. The tool was fairly accurate as regards testing voltage, testing capacity, and giving us a good indication of whether batteries were good or not. The cranking test was slightly different than the one I did the last day. The voltage drop was higher, and that may be the case, or maybe the case that I started the Jeep a few times to do recording, and that the battery hadn't charged up again. So there's a possibility that that happened there. The third test then, which we did, was the charging test on the Jeep. Difficult enough to do. I was trying to hold the camera, hold the testing equipment, and then operate the Jeep and read the instructions at the same time. So it's sort of a three-handed job, so to speak. But anyway, the way that works is there's an unloaded test, which is that vehicle idle. So that'll be around 700-800 RPM. There's a loaded test at 2,500 RPM, and they both read out in voltage then 14 point something or whatever they were. And the third test then on that is an AC ripple test. And the objective of the AC ripple test is to see whether there's AC current coming through the alternator into the DC system of the car, because it can play havoc with control modules and generally upset communication between modules. So the generally accepted practice is that anything over 50 millivolts of AC ripple coming through the system, it's probably time to start looking at replacing the alternator. The battery, if it's fully charged, can absorb some of that out of the system, but generally speaking, it's something to keep an eye on, and the objective of that test is to be as low as possible. So if it was like 200, 300, you're possibly looking at problems then. Okay, that's about it. If you have any questions, stick them in the comments down below. I'm no battery expert by any means. I'm only sort of learning as I go, same as everybody else. So if you do have questions of a sort of a technical nature, stick them in by all means, and hopefully somebody will come along who's a bit of a battery expert and might be able to answer them. Other than that, thanks for watching.